Alright guys, last thing is how do we work problems? If you got some charges, let me just turn off the field for a second. And so we put some charges here. Let's say we have these two charges, right? And you had to calculate the force between them. Not a big deal, because we know that they're going to attract each other, and so we can calculate that force using Coulomb's law, K, Q1, Q2 over R squared. It'll be attractive, and boom, it's pretty simple. You just put K in there, and you have Q1, you have Q2. This distance would be R, we'd square it, we'd be done. And so when you have just two charges, problems are pretty easy. Now, the issue comes when you have more than two charges, and this will happen to you. So if we put a third charge up here like this, and then I ask you to find, what is the total charge acting on this sucker right here? Say this one's positive, this is negative, and this is negative. What would the force be on this charge? So this takes a little more work, right? And what ends up happening is you essentially get a vector problem is what you get when you do this. And so we would have to do a couple different things. I'm going to show you on the board here. So I'm going to make this bigger. Alright, so here again, if we have these two charges, then it's pretty easy because they're going to just attract. And we do K, Q1, Q2 over R squared, and we'd be done. And that would be really easy. And I've already shown you how to do that. The issue comes when you have more than two charges. Like what if we have a third charge up here? And so we have this third charge, right? Gosh, well then how would we calculate, and so we want to know the total force acting on this one, right? So how do you do this? Well, it ends up being a vector problem, and so I'm going to show you how this works. Okay, so what we'd have to do is we'd have to do a couple different, this becomes kind of a lot of work because you have to do a couple different calculations in order to figure out what's the total charge acting on this guy right here. So here's what I do. First thing is I say, okay, I'm looking at this one, and I want to know what the force is. I'm looking for the force, right? Which way is this thing going to go, right? What's going to be attracted to this one? This one is negative. It's going to be attracted to that one, and so it's going to kind of go off in that direction. It's going to go that way, right? So here's what I do is I break it up into pieces. I say, what is this one going to do here? Well, this charge, change colors, this charge right here is going to make this one go that way. I could call that force of 6 on 3. Okay, and we can figure out what that force is. Force 6 on 3, right? We just got to do K, Q1, Q2 over R squared. And so for this, it would be 3 microcoulombs is 3 times 10 to the negative 6. That's what micro means. Micro is e negative 6. So this charge is 3e negative 6. This charge is 6e negative 6. And then there's a certain distance between them, right? And so we could just, whatever that is, let's make these 1 meter. So this is easy, 1 meter squared. Let's say that this distance is 1. And so that would be the force, this force. And I have to do that. That's the math I would do for that force. Now, the next piece is, what is this one doing to this guy? Well, this one would make it go that way. And that's the force of 9 on 3. Wouldn't this one be attracted to that one go that way? And so I'd have to do this again. So the force of 9 on 3 right? I still got this one, 3e negative 6. I got this charge, which is 9e negative 6. And let's say this distance is also 1, just to make it easy, so we have 1 squared. So I can get these two forces. Okay? So you got to do 2 pieces of math to do these 2 forces, which is not the hardest thing you've ever done. Now, what is the total force here? Well, this is where it becomes a vector problem, right? I have a force in the x and a force in the y. What am I going to do? Well, I'm going to add these vectors. I have an x force, I have a y force, right? And so what I get, magically, is I have to do Pythag. So whatever I get for this force, whatever I get for that force, right? This would be my x, and this would be my y, and then I would do Pythag. And that's how a bunch of these questions actually work, is you get these little right triangles, because, you know, as you can tell here, you have essentially what is a right triangle. And that's what happens. And so that's how you would find the force acting on one of those charges. Is essentially you just, all of a sudden you're doing stuff we did in the first six weeks. You're doing vectors in Pythag. And that's what happens. So I hope that makes sense. The practice problems in this module, it looks really complicated, but essentially that's all they're doing, is they're just breaking it up into pieces. And they're having to use Pythag. So I hope that makes sense, guys. Anyway, all right.